All right, so we're going to go ahead and do the last example from what should have been on Friday's notes, which was 2.6a. I just forgot to include it for some reason, but it doesn't really matter because we learned everything we needed to learn. It wasn't very smooth with period 2. Hopefully they watched the video, and I told them today, watch the video, and I'm going to be real with you. This example we're about to do is not, what's the word? It's not that it's a hard question. It's a very tedious question. Let's put it that way. And the reason why is because we have to compare 3 different residual plots. Unfortunately, our calculator does not have the ability to do 3 different residual plots at once. So we have to do them all one at a time. So rather than find the quadratic model and the exponential model and a power model, which just means x to some exponent, and then try to find the residuals, we're going to do a quadratic model, look at its residual. Exponential model, look at its residual. Power model, look at its residual. Cool beans? All right, great. So we do have to enter this as L1 and this as L2. Just so you know, the context of the question says we're looking at views of a podcast, and it says in months. So our L1, our X values are months. And we have to keep that in mind because when we get all the way to the end, it asks the question in years. So we just always want to keep context of the question in mind. We're going to go to second mem, clear all lists is command 4. Yep, clear them, done, my lists are cleared. Stat edit, and there they be. Double check that you typed it all right because in period 2, of course, I typed something wrong in the list and nobody caught it. It's not their fault. We didn't catch it until my answer didn't match theirs. So always make sure that you double check your lists. Okay, double checked. We're good. Again, double check, make sure you typed it right. Okay, we are double checked here. So we're going to find 3 different models, a quadratic model, an exponential model, and a power model, but between each model, we're going to figure out what the residual plot looks like. Cool with that idea? Yes, Mr. Brown? Fantastic. Great. First things first, the quadratic model. Stat, calc, scroll down to quad regression and hit enter. You don't need to store this equation because we're not actually going to graph this equation. Now, if we were trying to graph the line and the scatter plot to see if the plot looks good with the model, then we would want to go ahead and store it as y1. But that's not what we're doing. We're using the residuals to determine whether or not we have a good model. You guys all right with that idea? So because we're just talking about the residuals, I'm not going to bother storing this as y1. I'm just not going to bother. There it is. So that is my A, B, and C to 3 decimals. Is going to be 0.013x squared minus 0.205x plus 0.843. Now, I taught you about r squared, the coefficient of determination. It tells us how much of the variability in y could be attributed to the change in x. Just so you know, analyzing r squared values is not in AP Precalculus yet. It might be in the future, but right now it's not. So even though we have an r squared value, we don't need to know it. Now, I'm going to write it down just because worst case scenario, maybe you have to cheese something on the AP exam and use your knowledge of r squared to help you determine if something is a good model or not. So I'm going to write it down. It was well, if you take it to 3 decimals, it actually rounds to 0.97. So I'm going to write it, but it's not required that you know it. Now, I'm ready for my residual plot. Go to the y equals menu. I still have something hanging on in there. And what we're going to do is, and you know what? I actually don't trust it, because every time I try to do it, it throws an error. So I'm going to go back to stat, edit, and for L3, I'm going to go up to L3 and hit enter. And I'm going to go to second stat, and I'm going to name L3 by pushing up the resids. That's the residuals. So second stat, from me, I have to press up because it's at the bottom of my list of names, and hit residuals. And I go, yes, please give me those residuals. And there they are. Now I want to analyze this residual plot. That means I need to see this residual plot. I can see my x values. They're the numbers 1 to 42. But look at these, what are going to be my y values. They range at the lowest -1 and change, and at the highest 1 and change. So on my y values, I'm going to go to -2 and +2. You cool with that idea? Okay, so window from 0 to, I don't know, 50? 50 feel good? And I'm going to go -2 to +2. How do I get what? How did I get L3? Go to stat, edit. I highlighted L3. I hit enter. Second stat, residual. And hit enter. Now I'm going to go to my y equals menu. And I'd like you to see that I have no scatter plots turned on. I'm going to do a second stat plot because I want plot 1 to be on, and I want it to be L1 versus L3. L1 was my x values. L3 was my residual values. Now when I hit graph, I should have that many residual plots, or dots, excuse me. Boink, there they are. Do we see a pattern? Or is it relatively randomly scattered? That's pretty random. That's pretty random. I'd say there's no definite pattern at all in that. None at all. Now we are going to have to keep this idea in memory, unfortunately, because there's no way to store this residual plot. Just can't do that. Okay? But I would like you to notice that some of these residual values are relatively far away from the x-axis, right? So if any of my other residual plots get me random, but closer to the x-axis, that's probably the better option, right? Alrighty. Now, I'm going to go to stat, edit, and I'm going to clear L3. There, L3 is clear. The reason why is because I'm now going to find my exponential model. Stat, calc, exponential regression. Again, because I'm not plotting these dots and seeing which graph goes through them best, I'm not going to store it. I'm just going to ask the calculator to give me the equation, and there it is. It's going to give me about 0.239, and my exponential base is about, to 3 decimals, actually rounds to 1.11. Again, it's not part of the AP curriculum, but this R squared value is 0.98. I'm expecting to see a better residual plot. And by better, I mean still random above and below like we had before. But this time, I'm expecting those residual values to be closer to the number 0. So huddled a little bit better around the x-axis. So stat, edit, go up to L3 and highlight it, hit enter. Second stat, residuals. Oh boy. So I got a better R value, but my residuals are, well, some of them are really far away. Just to make sure, because I've been having trouble with technology this morning, did your residuals come out the same as mine? Yeah. They did? All right, just making sure. Now, in order for me to be able to get these on my picture, I am going to have to zoom out a little bit on my y-axis. Man, I'm going to have to go all the way up to above 2 and below 3. I'm going to have to go to 4 and negative 4, I think. Wow, that is... So what would you say about that model? I mean, I'd say that for a while, it was a great model. And then towards the end, it started to not look so good. I mean, look how far away from the x-axis these residual values are. So is it random? Yeah, there was no pattern. But large residuals at end. Now let's get our power model. Again, go back to stat and edit and clear that list. So if I had to make an argument about which one I thought was a better model, I'd say for the whole set, the quadratic model was better. Only because at the end, this thing's residuals were way off base. Stat, calc, power model is the next one down from exponential. So it's just a power regression. And maybe you'll notice why that might be why R squared is not part of AP's curriculum. Because even though this is a better R squared, I feel like this was the better model. Power regression, not storing it for anything. So about 0.116 x to the 1.155. And its R squared is way off base, 0.877. I'm not even going to write it down, it's so far. I'm expecting the residuals to be awful, so to speak. Well, let's track them down. Oh, you can't see the equation. Let's track them down. Stat, edit, go to L3, enter. Second stat, residual, and wow. Our window will fit everything except for that last one, 7. Oh my gosh, that's awful. I'm going to have my Y max go all the way up to like 8. I'd say that's not even random. It looks almost exponential, doesn't it? I'd say there's kind of a pattern to that. I mean, so based on the model, based on our findings, which one has the best, which one fits the data the best? I'd say exponential does. Excuse me, quadratic does. I would argue that quadratic fits the best based on just the way it looks. Comfortable with that idea? I'd say quadratic because residuals stay closer to x-axis. and then it says what would be the expected views in 5 years. What units are our x's in again? Months. So that would be 60 years. So unfortunately, we do have to plug 60 into this. But I mean, that's about as bad as it gets. I got about 35.343. Did you guys get that? Okay. And that's in millions. There we go. So if you have to compare residuals, unfortunately, you are going to have to generate them separate from one another and just try to keep them in your own personal memory because the calculator can't. I feel like that is a massive oversight on the programmer's part. I feel like I should be able to generate different residuals based on different regressional models, but that's me. Whatever. Cool. Are we ready then to move on to section 6b, 26b? Yes, no, maybe so? Nobody has any questions about this? No? Okay. All right. So again, the second part of this lesson is really about determining based on what we see what's a good model and also situationally what's a good model. So we want to be able to look at both the residual plot and our endpoint behavior when we're choosing an appropriate model. For example, we thought that quadratic was the best fit for this. But we know that quadratics point up in both directions, right? Imagine we were talking about the podcast views before this date. Let's say, for example, the podcast started a solid year before this. That would mean my x values had the ability to go to -12. But if the vertex of my quadratic is anywhere near this, we're talking about a podcast that for some reason had high views that came down and then came back up, which would be strange. So situationally, I would say a quadratic wouldn't make much sense of this for this if it existed before this date. Now we don't know enough information about it, so we can't really say that. If the residual plot follows a regular pattern, then there is a behavior that is not accounted for by the model you chose. We already know that. Our residual plots need to be random and they need to stay relatively close to the x-axis. If the residual plot has no pattern, then the regression equation most likely models all but random fluctuations in the data. Okay? But also talk about the situation. Your biology teacher has bacterial cultures for a class of 24 students. Each student is measuring the number of bacteria, Y, in his or her culture at intervals of time, X hours, during the day. The results are shown in this table. It says find a power function regression model and R squared. Do you see the size of this table? All of those are X values. All of these are Y values. It would take us several minutes just to put this in our table. I really don't want to. Instead, I'd rather talk about what do I want to say? I want to talk about what makes more sense as far as the situation is concerned. Okay? After we found these things, and by the way, I hope it's obvious that they're both going up and to the right. As time goes on, the number of bacteria is growing, correct? Who cool with that idea? Here's what I would like to do. I'd like to jump all the way down to part C. By the way, this is the scatter plot of the data that we have up here. I would like to jump down to part C And this is literally because of the size of the data set. It's just huge. And I would like to talk about what our models would give us. We would get an exponential model. But exponential models, we know, go on forever in both directions, correct? An exponential model would have a graph that looked something like this. Can we agree to that? It would look something like that. A power model, just flipping this over for a moment, just means number times x to an exponent. If you do number times x to an exponent, you will always get a graph that starts at 0, 0. Now, I don't know which one of these has a better r or r squared or anything like that. And I don't know which one has the better residuals. What I do know is there's no such thing as spontaneous generation of life. Can we agree to that? So does a power model make sense? If you start with 0 bacteria, can you start growing bacteria? No. So I would say as far as the situation is concerned, this is not feasible. This one, which has a starting number of bacteria, is feasible. So which model would better represent the data set? I would say that the exponential does. Oops, I can't spell. It is a starting value that is not 0. Whereas all power functions do have a starting value that is 0. Now, in second period, I chose this one because I wasn't thinking. And let me tell you why I chose this one in second period. In second period, I was thinking this one's a better model because this goes on forever in the past. And we would have the number of bacteria forever and ever and ever getting diminished and diminished and diminished and diminished, which would approach 0 but never actually reach it, and have fractional bacteria and things. But the more I thought about it, the more I realized that this one requires life to spring from nowhere, which as far as our scientists have been able to find is not possible. We've tried, but we haven't done it yet. So because this one has a starting population that then grows, that's the better model. So using the exponential model says find the number of bacteria in the initial sample, make a prediction for the number of bacteria present at 24. Look, we don't have an equation. We don't have an equation. So how would I figure out the number of bacteria initially? What does it mean to say initially? What? The y-intercept. And if you're on the y-axis, what is x? 0. So if you wanted to know the initial value, you would substitute in the value t or x equals 0. Since it's time, they said x. They said x. So initial population, just use x equals 0, which is why we're actually choosing the exponential model as the better fit, because it has a population at the beginning. If we wanted to make a prediction for the number of bacteria at 24 hours, what would we do? You plug in 24. Part E, if we had a model, how would we figure out when it equals 10,000? Yeah, you just set y equal to 10,000 and do second trace intersect. So I would graph my model as y1. I would graph 10,000 as y2, and just use second, trace, intersect. And remember, how do you spell intersect? It's an S, right? There we go. We just didn't feel like typing that giant table of data in. 7.5 hours, so you actually typed it all in? Okay. 7.5? Wow, gets there pretty darn quick, doesn't it? Anyway, the point is we know how. So I don't think that we've really missed out on much by me not doing it. Because we've been doing regression and setting things equal since the beginning of the school year. Yes? You guys remember doing that with straight lines? Way back in like chapter 1-ish? Okay, great. How about a data table that's not so massive? One we can actually type in. While driving down a dirt road, you puncture the tire of your truck. The table below shows the pressure, Y, what? Or a country song. Scary movie or a country song. A scary country song. Anyway, the table below shows the pressure, Y, measured in pounds per square inch, PSI. That's supposed to be of air in the tire at any given time, X, measured in seconds after the tire was punctured. Clear, enter, clear, enter, clear, enter. Hold on, I hear something in the back. Did you happen to delete a list you weren't supposed to delete? Okay. Come up to where yours says, whatever one you deleted. Did you delete L1? You deleted L3. So go to L4, highlight it, hit enter. And, oh, actually, no, never mind. You're supposed to do second insert. Like, there we go. Right here. Second insert. There. And then you would do L3. And it'll be back. Did it work? Yeah. There you go. All right. Boop. X-axis goes by 5s. All right. This is the one I typed wrong. So make sure you double check your numbers as you type them in. Looks good to me. It says find an exponential model that fits the data and then find R squared. Remember, AP is not going to make us analyze R squared, but it is good to have knowledge of it. Stat, calc, exponential. Do I want to store it? Plot the equation and the scatter plot on the same screen. So yes, we're going to want to store this one because we want to see it go through its dots. We're going to want to store it. So come down here to store regression equation, vars, yvars, function, y1. There, so that'll save it as y1 for me. Actually to 3 decimals gets me 0.88. Exponential base is 0.955. And our R squared value is 0.989. That is a very good R squared value. Look how close to 1 that is. As far as plotting this thing, I'm going to go to my window first. I'm going to adjust my window. My X values start at 5 and end at 50. So you could go from 0 to 50. I'm going to go from 0 to 60 just so I can see all of the dots clearly on the screen. I'm going to go past where the data goes. And my Y values, the biggest one is 28, so I'm going to go up to 30. No, excuse me, that's my minimum. I'm going to let my minimum go to 0 and my maximum go to 30 and count by 3s. And then I'm just going to hit graph. Wait. Go to y equals. We need a scatter plot turned on. So second stat plot. And on plot 1, I need actually to do this one as L2, not L3. So second L2. L2 is above the number 2. There we go. Now when we hit graph, we should see all of these dots and the equation that it created for us. When I hit graph, there's my dots. And we were expecting it to fit really well. I mean, look at this r squared, right? It says, does the exponential function fit the data points? I'd say it does. 1, we know r squared is very close to 1, but first of all, we know r squared is very close to 1. Also, look at these dots. They are relatively scattered above and below, but closely to the predicted line. I would say it fits because actual values are close to predicted, above and below. I mean, look at it. It's great. It's a fantastic model. Now, using the model, what was the pressure before the tire was punctured? That means before time has started elapsing. So what x value would I use if I was trying to calculate this? You'd use 0. And if you use x equals 0, what you get is 33.88. They gave us the residual plot. It says the residual graph is shown to the right. There it is. Does this match your calculation? What does it tell you about the validity of your regression function? Well, this is showing residual values that are close to predicted values above and below. I'd say this matches. But if you weren't sure, you could do the residuals yourself if you wanted to. You could go to Stat, Edit, go to L3, hit Enter, second stat residual, and hit Enter. If we're trying to match this, though, you'd need to see 1, 2, 3, 4. It looks like it went up to y equals 4 here and negative 1, 2, 3, negative 3 here. So on our window, my y minimum would be negative 3. My y maximum would be positive 4. I'm going to go to my stat plot and change it to L3. That way it uses my residual values. L3 is right above the number 3. Looks like theirs. So yes, it matches. And what does this tell you about the validity of your regression function? It's a good model. It's valid. Because residuals have no pattern, stay close to x-axis, and are above and below. Say, and scattered above and below. It's a good residual plot. What do you think? We've been doing residuals for a while. But are you comfortable creating regression models? Are you comfortable creating scatter plots? Are you comfortable having the calculator generate residuals and then plot those? And then are you comfortable analyzing what the residual plot tells you. If the answer to all those questions is yes, then you are right on track with this lesson. If there's anything you need to ask me, please do. No? All right. Well, let's look at example number 9 then. A set of data has an upward trend. A set of data has an upward trend, which is showing you right here. This is the actual data plot. It is not clear whether the best fitting function is linear or exponential. These are the residual plots. Based on these two residual plots of this data, which regression model would you say fits better? Based on the residuals, which one would you say fits better? Jack W is holding up 2 fingers. You guys agree? Do you think this one's better? I do too. And here's why. I'd say this one has somewhat of a pattern to it. It almost looks like a quadratic. I'd say there's too much of a pattern here for my liking. Whereas this one, they're just above and below. And I mean, yeah, it's getting a little far away, but I mean, that's further away. I'd say that that's further away. And these, they're scattered relatively evenly spread above and below. So this one's the better model. So better because no pattern. And I'd say this kind of looks like has somewhat of a quadratic pattern. And again, spread relatively evenly above and below, scattered, stayed pretty close. And I think that is as far as we need to get today because I plan on finishing the lesson tomorrow.